In this video, we're going to talk about pH calculations and some of the other acid-base calculations, KW, things you're going to see. So we're going to look at number 83 on page 437, and it reads, what is the pH of apple juice that has a hydronium ion concentration of 3.2 times 10 to the minus 4 molar? Calculate the OH, the hydroxide concentration, and is the apple juice acidic, basic, or neutral? So let's talk a little bit about the pH scale. pH scale is based upon the calculation of pH. pH equals the negative log of the hydrogen ion concentration, the hydronium ion concentration. And 7 is the midpoint for pH. It's neutral. If you go above 7, 8, 9, 10, this area here is basic. If you go below 7, so 6, 5, 4, that side's acidic. So if you have a pH less than 7, you have an acidic solution. If you have a pH greater than 7, it's a basic solution. Sometimes in books you'll see that the scale goes from 0 to 14. This is not really the case. You could have negative pHs and you can have pHs higher than 14. They're not very common, but it does happen. So this question's asking for the pH of a 3.2 times 10 to the minus 4 molar solution of hydronium ions. So pH equals negative the log of 3.2 times 10 to the minus 4. All right, so you put that into your calculator, 3.2 times 10 to the minus 4, depending on the calculator you have. You can do that many different ways. If you don't know necessarily how to use your calculator, you could email us, or you could try looking it up online as well. Just make sure you give us your model number if you email us about it, so we can tell you specifically for your model. So if you put 3.2 times 10 to the minus 4, you hit the log and then you negate that, you're going to see the pH is a pH of 3.49. So 3.5, 2 sig figs here, so pH is 3.5. Now, let's go to the last question. Is this acidic, basic, or neutral? Well, if neutral is 7, less than 7, and 3.5 is less than 7, this is going to be acidic. All right. Now let's scroll down just a little bit, because this next question, let me try to keep this information there. This next question is about the hydroxide concentration. Okay. Now, in acid and bases are kind of an interplay between the two species, hydronium ions, the acidic portion, and the hydroxide ions, the basic portion in water, in solution, aqueous solution. And they play off each other because when one goes up, the other has to go down. There is actually a constant, a water dissociation constant called Kw. This has to be 1.0 times 10 to the minus 14th, and it equals the concentrations of both hydronium and hydroxide multiplied by one another. Okay, and you'll find if you do the math, if both of these are equal, okay, so this would be x squared equals 1.0 times 10 to the minus 14, you'd notice then that at a situation where they're both equal, they both equal 1.0 times 10 to the minus 7. And this would give you a pH of 7. And that's why a pH of 7 is neutral, because the acid and the base portion are in equal concentrations. So you don't have an acidic or a basic solution. They cancel each other out concentration wise, and you have that pH of 7. But when one goes up, let's say the concentration of H3O goes up, since this is a constant, when you multiply them, they need to be 1.0 times 10 to the minus 14. This is going to go down. All right. So the interplay between the two, when one goes up, the other has to go down. At only one point are they equal, and that's 1.0 times 10 to the minus 7. If this happens to then, let's change a different color. this happens to go down, then this one's going to go up. All right, they are indirectly proportional. Okay, and as a result of being indirectly proportional, when one goes up, the other is going to go down, and vice versa. But when you multiply these two concentrations together, you must get 1.0 times 10 to the minus 14. So let's go back to that middle question. What's the OH concentration if this is 3.2 times 10 to the minus 4th? All right, so let's scroll back down, all right, and write what we know. H3O plus hydronium ion multiplied by the hydroxide ion concentration must be 1.0 times 10 to the minus 14. But we already said that this is 3.2 times 10 to the minus 4th. All right, so we have that. So we're going to need to get the OH concentration by itself. We divide both sides by the 3.2 times 10 to the minus 4. We do this math plugging this into our calculator, and hopefully we get somewhere around 3.1 times 10 to the minus 11. That's the concentration of OH, the hydroxide ion. And 3.1 times 10 to the minus 11 multiplied by 3.2 times 10 to the minus 4 better equal 1.0 times 10 to the minus 14. Okay, so hopefully that'll show you how to do some of these. There's one topic not involved in this question that I want to go through, because some students have the problem converting pH over, when you're given a pH, how you get concentration. So you have pH, and how do you go to H3O plus concentration? Well, let's scroll down a little bit and I'll show you. So here's our formula. If we are given the pH, how do we solve the OH or the H3O plus? Okay, how do we get this hydronium concentration? All right, well, algebraically, we'd multiply both sides by negative. So we get negative pH equals log of the H3O concentration. We take 10 to the x to both sides. So this will be the exponent x, and this will be the exponent x, and that's 10 to the minus pH equals, log is base 10, so base 10, 10. They cancel each other out, and you're just left with the hydronium ion concentration. So in your calculators, if you're given a pH, if you make that pH negative and then you type your 10 to the x button, it better give you the H3O concentration. All right, hopefully that'll help you out.